Hey everyone, in this video we're going to do a street battle head-to-head matchup between two intake options for the Mk7 GTI. Got the Blaze Performance Atom Race V2 right there. And next to it, what's in the car right now? The stock GTI airbox with some modifications. So this, beginning with the duct, gone ahead and opened up this side so you can get some additional air and going straight in. On the passenger side, that is duct tape to keep the hot air from the engine compartment from getting pulled in. The airbox has in there a BMC panel air filter. Below it, the baffle snow guard panel that's got holes in it, or slots in it rather. That's been removed. MST's accordion hose, which is a 3-inch at the elbow. So the stock one is 2.75 inches. This is a 3-inch one, so we've got a larger hose there, inlet hose. Also, it's smoother inside as well. And then tucked back in there is the DBV2 turbo inlet elbow. So as far as the Blaze goes, well, there's not a whole lot to say about that. It's the Blaze Performance Atom V2 Race intake. So what is the test actually going to consist of? It's going to be just a single gear, 4th gear pull up from about 2,000 to around 6,500 RPM, and logging the car's engine variables, and then we're going to come back and take a look. Aside from changing the intake, everything else is going to stay the same. This is going to be done within a couple of hours of each other. So the air temperature should be the same, but that will be something that I'll talk about once we get to the results. Collecting data from the GTI operating with the Blaze Performance Race intake and the modified stock GTI intake was successful. Now we're going to go over the results. To start, one thing I want to just review is the correlation between wastegate duty cycle and the outside air temperature, and how much of a contribution that temperature does have on the wastegate duty cycle. So on this chart here, you've got the engine speed along the bottom, which is during the pull, and then the vertical axis is the position of the wastegate. And then over in the legend in the top right is the temperatures. So this was the similar intake setup prior to this particular test, and went out and logged the car. One was a cool day, 48 degrees, and there was one that was 63, and then one that was 85. And what this really shows here is that at the 48 degree temperature, the turbocharger is working the least hard, and as the temperature goes up, you get a little more effort by the turbocharger to compress that air, and then as the air gets warmer or less dense, it has to work even harder. So that's a pretty decent increase. When you look down, especially like at here, you got 45% and you're going up to 65%. So a 40 degree temperature difference produces a 20% drop or 20% increase, depending on how you want to look at it, in the turbocharger wastegate duty cycle. So that's something important to keep in mind when you're looking at results from someone where they've swapped apart and said that they've seen some sort of a change in the wastegate duty cycle, that the outside air temperature is a significant factor leading or contributing to what that wastegate duty cycle is. So you want to make sure that's being controlled, and if you're going to try and compare a product, which was the situation I was facing here, was making sure that the temperature outside was the same. And in this case, this is the outside air temperature. The light line here is the stock airbox, and the darker blue line here is the Blaze. So you got 64.4, 63.05, so less than 1.5 degrees of difference. Very similar. So that's good for being able to compare the other values that we're looking at. Intake air temperature, no surprise, very similar as well, with the outside air temperature being the same and the intercooler being the same and going out to the same location, so the car is basically driven the same amount. you've got less than a 2 degree, again around 1.5 degree temperature difference on intake air temperature. As far as the turbocharger and what it's doing, boost pressure extremely similar. There's a little noise as it varies here and there. You see some segments the stock is a little higher than the blaze, and then blaze is a little higher, but they tend to trade back and forth, and even at the very top where there's a little difference there, but you're talking in the neighborhood of 0.2 of a psi. So very similar, and that is most likely just noise that happens to be breaking out at that point. So finally, the big variable of interest was the wastegate duty cycle. And again, you see that random noise as the pull continues. But of most interest, the last time when we were using the MST 53mm outlet elbow, the wastegate duty cycle with the stock intake went up a little bit more compared to the baseline, which is the blaze in this case. And here, when we switched over to the DBV2 elbow, which is a 55.3mm outlet, very similar to the blaze at 56mm, you see those two lines come together. So pretty good evidence that having a elbow outlet to your turbo sized appropriately for that turbocharger can make a little bit of an improvement compared to something that maybe is not as close to the size of the turbocharger's inlet. In conclusion, switching out that inlet elbow to the DBV2 made a difference and brought the two intakes on par. So the big three takeaways from this: number one, modified stock airbox supporting 500 wheel horsepower, absolutely, and probably more. Just making sure you have the right components that you're modifying it with. Number two, blaze performance intake, outperforming competitor intakes. I didn't do it here, and I doubt it's going to be doing it with other ones unless you cherry pick some very specific poor performing intakes. And lastly, this test really emphasized the importance of that inlet elbow, sizing it correctly for the turbochargers you're using it with. It's a 56mm inlet on a turbo. You want an elbow that's 56. If you have a 56mm inlet on the turbo and you're using a 53, we saw that there was less flow performance. I've seen a number of people doing comparisons of intakes where they have put on a intake that's designed for a hybrid turbo, compared it with an intake that has an elbow designed for a stock turbo, seen big differences, and then pointed to the intake. No, it's the elbow. So that's something to key. And also, just as an aside, we've seen the difference that the outside air temperature makes. So that's a good question to ask when you see a hardware change being done and they're looking at wastegate duty cycle, to make sure that the air temperature is at least within a probably 10 to 15 degrees at most difference, depending on how finally you're trying to split hairs on differences, which that's a whole other issue. All right, until next time. Next project is in the works.